Hello and welcome to another session on DataStage interview questions and answers. This is the second video in the series, and if you have missed the first video, then you can click on the link above and you can check out that video as well. Now this video is going to be all about the transformer stage. So we are going to look at some scenario based questions as well as conceptual questions. So before we begin, I would just like to take a moment and request you all to please subscribe to our YouTube channel. We have a lot of data warehousing tutorials and we are planning a lot more, so they'll be coming out soon. So let's begin the session for today. Now the first question is around the performance of the transformer stage in a DataStage job. So let's read the question. A DataStage job needs to copy input data into multiple output streams. One developer has used the transformer stage to implement this. Another has used the copy stage. Which is a better design? Now to be able to answer this question, we have to understand that how the transformer stage executes in the back end. So a transformer stage actually requires a C++ compiler because it is compiled into the C++ code. So one external hardware element is required. That makes the transformer stage a very performance heavy stage. So we have to be very careful in using the transformer stage, and we must use the transformer stage only when it is absolutely necessary to do so. So a good design tip is to avoid the use of too many transformers in the DataStage job. Now what can be done and in which scenarios we should avoid using the transformer? So for simpler operations, like in the requirement, in this case, we have a simple requirement to copy the input data to multiple output links. We are not performing any calculations. We are not doing any derivations. So in this stage, we can use the copy stage. A copy stage is a native DataStage stage. It's very light stage in terms of performance. So we can use as many copy stages as we wish in a DataStage job. So for simpler operations like mapping the input data to the output columns without any derivations or transformations or calculations taking place on them, or even if you need to rename the columns, a copy stage can be used for that purpose. For dropping the columns, so you do not want to propagate all the input columns to the output, you can use a copy stage for this. And for implicit type conversion, so there is, let's say, varchar 10 column, you want to map it to varchar 50 column, then you can use a copy stage. If there are explicit type conversions, like you want to convert a string to a date type, then you can use a modify stage. Now there are scenarios in which you will have to use a transformer stage, and one or two transformers in a DataStage job would not make the performance too bad. So we can go for the transformer stage, because in the transformer stage we can combine a lot of operations. So let's say we are copying the data from the input to the output, and though there are not too many operations or derivations involved, we need to trim the data. So we need to trim the spaces out of the data, and then at the same time we need to do some type conversions as well. So in this case, instead of using a modify stage and a transformer stage, we can combine the logic in the same transformer stage. So it is a wise idea to use a transformer stage in this case, because you can combine a lot of logics in this stage. But if the requirement is really simple, and it's a simple extract job, just copying the input data as it is to multiple output streams, then use a copy stage. Let's move on to the second question. Now this basically tests your knowledge of the way the data types are stored in the DataStage engine. So you need to understand how many bytes are required when you're doing your type conversions and things of that sort. So source column data type is decimal 8,2. It needs to be mapped to an output column of type string. How much length needs to be defined for the output column? So the question here is that we are converting a decimal data type to a string data type, which could be a char column or a varchar column, and we need to define the appropriate data length for that. Now that makes it necessary for us to know how many bytes does a decimal column actually need for storage. So if it is a decimal 8,2, how should we understand? How should we interpret this? A decimal 8,2 means 8 is the precision and 2 are the number of decimal points or decimal digits after the period operator. So if you can see in this example, in the way it is explained in the slide, then you have, if you call it decimal A2, then you have 2 digits. So you can see here 2 digits after the decimal point, which is your period operator over here, and then 8 is the total number of digits. So now you have total 8 digits. So for making it a total of 8 digits, you have to subtract the 2 digits after the decimal, so that makes only the 6 digits which are available for the integer portion of this decimal. So you have 6 digits in the integer portion, then you have 2 digits in the decimal portion, that makes it a total of 8 digits. Along with that, you have this period operator which will occupy a byte, and you also have a sign byte at the very beginning of the decimal, that also occupies a byte, and the value that you have in this is a plus or a minus. So if it is a positive number, it would be blank. If it is a negative number, this would have been a negative over here. So the total number of bytes required by this decimal 8,2 data type are going to be these 8 digits plus 1 byte for the period operator, that makes it 9, and 1 byte for the sign operator, so that makes it 10. So the total number of bytes required for storing a maximum decimal value that would occupy all the 8 precision digits and 2 decimal digits would be varchar 10 or a character 10. Okay, so you need to define the string data type correctly by interpreting how much data length is needed for the string data type. And if you do not define it correctly, let's say you defined it as varchar 8. So you thought that decimal A2 means the total length is going to be 8, and you defined it as a varchar 8, then your DataStage job would fail, the transformer would fail, because the varchar 8 would not be able to contain the whole value of the decimal field. So we have to be very careful in defining the correct data length when doing type conversions, especially from decimal to string. Okay, so the next question that we have over here, this is based on again a very important feature of the ETL design in general, and that is your validation of input data. So whenever we have some input data or the source data, we might be getting some invalid records. So we have to make sure that whatever records are passed to the transformation part or the transformer stage are the valid input records. So we need to validate the data. Now this validation can be of multiple types. The validation can be a data type validation. It could be a null validation. It could be for the duplicates, invalid data, and so on. So the question here is that a source file has all the columns defined as string. Design a job to validate that the input column, date of birth, is always a date value, else reject the record. So many times when you're reading some input data from a file especially, you would not have any data types defined. You can just read all of it as string columns. And sometimes in many legacy systems, even in legacy databases which act as source systems, all the columns are defined as string columns. Now when you're reading, let's say a column like a date of birth column or a start date column, an end date column, or any date column, or any column which can have only numeric value in it, let's say there is a column called age, so we can only expect some numeric value in it. So we need to make sure that whatever data is coming from the source, because in the source it was defined as a string, so by mistake somebody might have entered some invalid data. So we need to make sure that whatever records we are passing to the next stage are valid records, else we have to reject those records. So how can you implement this in DataStage, in the transformer stage specifically? So it's a very easy way to implement these kind of logic, and we should be aware of this. These are very important functions in a transformer, and that is the isValid function. Now this isValid function has various, it has a lot of variations. So you have an isValid date, which can be used specifically for validating a date column in the format that is given on the slide. You also have a isValid timestamp. So if it is, you're also validating, your data is coming with a timestamp, and you need to validate that it's a valid timestamp value and not some abstract ABCD value, then you can use the isValid timestamp function. if you do not find any function that relates to your particular data type that you want to check, or if you want to keep it generic, then you have this very powerful function which is the isValid function. Now in this isValid function, what you can do is you can just specify the data type over here, whatever data type you are validating on. So in this case, in the example, we are validating that it's an integer value. So the data type that has been specified here is integer 8 and your input column. So your output would be in terms of 1 or 0. If it's a valid integer value, your output would be 1. If it's an invalid integer value, then your output would be 0. And then that is the way you can identify the records, whether it's a valid record or an invalid record. And for invalid records, you can specify to reject those and put them in a reject file or a reject table or whatever as your ETL design. So this is a very important function, and everybody must be aware of this function because this is also a very important part of the ETL design. Okay, so the next question again is basically on some of the very important transformer functions. So a transformer is powerful because we are able to apply all these functions within the transformer apart from some other features of transformer like looping and stage variables. So apart from this, there are a variety of functions that can be applied in the transformer depending on your requirement. So there are some common functions that we should be very familiar with, and we are discussing some of those functions here and some of the most common scenarios that you will see in your DataStage jobs. So here the question goes like this. Source file has a single column called name. The values in this column are a combination of first and last names in the format last name, comma, first name. Design a DataStage job to extract the first and the last names. So this can happen in various scenarios. This can happen with the name field specifically. This happens a lot of times with the address field. So in the address field, you have the street number, your apartment number, your street name, your city, your state, your zip code, all combined into one single column, and you need to identify the various parts of this address. So this is a very common scenario in terms of these kind of columns. Again, we have a very powerful function that can be used in these scenarios, and that is the field function. So the way the field function works is basically by identifying your delimiter on which you are trying to split your data. So in this case, we know that we have a delimiter called a comma, and the part that appears after the comma is the first name. The part that appears before the comma is the last name. So based on that, whether we want the part before the delimiter or after the delimiter, we can use the field function. Now here we have to mention another function that is also very important and very popularly used in these kind of scenarios, and that is the index function. Now index function basically works by identifying the position of the delimiter. So this would identify that at what position, at which character, number of character, the delimiter has appeared. Now this function is very powerful in cases where we want to identify the exact length of the string between the various delimiters. There might be different kind of delimiters in the same source column. For example, if it's an address column, there might be a delimiter which is a space, a single space, a comma, or a hash column. So there might be different kind of delimiters based on which we want to identify the data, and then we want to know the exact length which we are picking up. We also might be wanting to pick up only those many characters which can fit into our output column. So many times it is the requirement in the source column, the data might come in which is of 10 digits or 10 characters might come in your street name field, but in the output we have only defined it as a 5-character field. So we have to identify the exact length and then cut it accordingly. So in all those kind of scenarios, the index function is very helpful. So these are two of the very important string functions that are helpful. Now this question is basically again around one of the other very important features of transformer, which are its stage variables. Now a transformer is the only stage in DataStage which allows you to compare the data between the records. So you can compare the values of the previous record and the current record, and only a transformer stage allows you to do so. And in the transformer, the feature that allows you to do so is using the stage variables. Now to understand the stage variables, apart from the stage variables, there are okay, we did not read the question. I think let's read the question first. The question is that in a transformer, what is evaluated first, a constraint or a stage variable? So we have to understand the various features in a transformer, which are the stage variables, a constraint, a derivation, and so on. So we have to understand what would be evaluated at which point. So a stage variable or a constraint. A stage variable is basically used for making all these comparisons or for defining derivations, which are used multiple times in your output column derivations. A constraint, on the other hand, is basically a filter on what kind of records you want in which of the output link. That is kind of a filter. So which would be evaluated first, a stage variable or a constraint? So here we have to understand that a constraint can use a stage variable to define the filter, and that is why it is necessary that a stage variable must be evaluated first and then a constraint would be evaluated. So we have to understand the order of the execution of all these different properties in a transformer. A stage variable is always executed first, followed by the constraints and then the output derivations. Now another thing that we need to remember is that the stage variables are evaluated from top to bottom, and we will see this in another question. What is the importance of this statement that the stage variables are evaluated from top to bottom? Okay, so next question, how can you generate a unique ID using a transformer? So many times we need to generate a unique ID, like an identity column, so with values like 1, 2, 3, 4, 5, 6 to identify unique records and so on. Now in many places you'll see that this is one of the derivations that you can use, at partition num plus num of partitions into at enrow num minus 1 plus 1. Okay, so you can use this, but the thing that limits the usage of this derivation is that we are assuming here that the records are equally partitioned or equally distributed between the different partitions. So in those cases we can use this derivation. Now all this at partition num, at num partitions, what are these? These are all system variables which are available by default in a DataStage transformer, and you can use them as it is. For example, there is something called at false, which will just replace the value with 0. And so at partition num is basically the partition number for the particular instance. At num partitions are the total number of partitions. So let's say you are running it on 4 partitions, then the total number of partitions would be 4. At partition number would be the partition number of each of those partitions. So it would be 0, 1, 2 and 3. The partition number always starts with 0 and not 1, 2, 3, 4, but it would be 0, 1, 2 and 3, and that's why the plus 1 at the end. So this is one important thing that we need to remember here, that the partition numbers start from 0. Then there's a list of all the system variables that are available in a DataStage transformer, and you can see them here. So this is one of the easiest ways of generating a unique ID. Now if you can, it's always advisable that an ID should be generated in some other way. Should not be generated in a transformer. Mostly it should be generated in your DataStage, in your database table if you're using a database, or you can try generating it through in your Unix scripts if you can. Otherwise, if you have to generate it in the DataStage, the most preferred way to do it is through the surrogate key generator stage that will generate unique values. They might not be in the proper in consequential order, but you have this option. You have a separate stage which is called the surrogate key generator stage, which you can use to generate these unique IDs. You can also use this implicit option in the transformer stage. So there's an option in the transformer stage itself to generate a surrogate key, and this has various options. You can use a database file to generate the surrogate key values, or you can use a normal file, Unix file, to generate the surrogate key values to store the surrogate key values. So the most preferred way, if you need to generate unique IDs in DataStage, is using the surrogate key generator stage. Okay, now this question tests your understanding of the null handling aspect of DataStage basically. So implement the below condition. If input column is empty, then set null, else trim the spaces of input column. And they have provided a note saying that input column is nullable. So if input column is empty, then we have to set it as null, otherwise just trim the value of the source column and pass it on to the output column. Now the ways to do this, let's say we write an if then else condition saying if trim input dot column A is equal to empty, then set null, else trim input column A. Now we have not done, please note that we have not done any null handling in this statement, and that's why this is destined to fail. Now why is it going to fail? We have not done any null handling, but we have to understand, because this might happen many times by mistake. We do not observe that it's a nullable column or whatever. Okay, by mistake we just write trim input column A, and your transformer stage is going to fail. And why is that? Why does it fail if we write it this way? Because we know that the column is nullable, so null is a valid value. Now let's say that there's a record with a value of null in this particular column. Now if we perform this function trim on this particular record which has the value of null in this column A, then trim of null value would result in null. So this statement, particularly the statement that we have written is if trim input dot column A, this whole thing would evaluate to null, and when this evaluates to null, the transformer stage or the data stage cannot understand what is happening, and it would simply fail the whole job. So that's why you have to be careful and do null handling. You could have used if is not null, then trim input dot column A, or and else just set it at check it for empty and then set it as not null or null, whatever is the requirement. So we could have done by doing the null handling by using the is not null or is null functions. Now a very good way of doing this, instead of using and writing all this if then else and checking is null and is not null, and some data stage is not very consistent on these functions as null and is not null. Sometimes you will observe that is not null does not work the way it is supposed to work, and we have to write not within brackets is null and so on. So it's not very consistent with these null functions. So a very good way, and the way that we should prefer doing it is, it's also a straightforward way, it avoids all these if then else statements, is use these functions which are like null to empty, null to value, and so on. Okay, so before applying any function, any other function, we have to do null handling. Now this particular function here, null to empty, it does the null handling on this column. So let's say if this was a record with the value of null, then the null to empty function would have converted that null value to an empty value. On top of that, we are going to trim it. So trim of empty is going to be empty. So if we would have used this, then we could have directly tested and set this as null. Let's say if this was a not null value, so let's say the value is 1 2 3 4, then what would null to empty do? It would not do any, it would not perform any operation on this, because it's not a null value in the first place, and you would directly go to the trim function and trim that value if there were any spaces in that value. So always use these functions, null to empty. There are many more functions like null to value and so on, or null to zero functions. If you're working explicitly with the numeric or decimal data type, then you can use that function. So these are very powerful functions. These are very useful functions as well. So try to use these functions instead of putting extra if then else and checking is null and is not null and so on. Okay, so now we have come to the stage variable part. So the question here is that design a job to implement the below requirement. Now you can see that there is an input data and an output data. The input data is a monthly data. So you have 12 months of data for sales of some product A. Now this example shows only one product, but they are supposed to be multiple products. So there would be multiple products. And you have the monthly sales figures for those products. Now in the output data, what we need is YTD, which is year to date. So basically what they are doing is for month 1, you have the value of 45. So year to date sales are going to be 45. For the second month, you have added the sales for the first and the second month. That becomes 75. So it's a cumulative sum. So for the 12th month, in this way, it would be the sum till the 12th month. So it is the year-to-date sales. So sales till that particular month, starting from the first month of the year for that product. So what we need is, in the input we have these monthly sales separately. In the output we want the cumulative sum or year-to-date values for the sales. So how can we implement this in the transformer or in DataStage? So we need to use the stage variables in this case. Now what the stage variables are doing here is, you have the stage with some name and we are just following some convention, some naming convention. So stg is to identify that it's a stage variable. Sum, so if input dot product, so let's assume this is the current record. If the product is not equal to stage product is down here at the bottom and it has an input dot product from the previous record. If it is equal, that means the same product, then previous month sales plus the current month sales, L reset it to the first month of sales. If it's a new product, that means you have the first month coming in for the new product, then just put the sales for the new product. Okay, and you can see that there are two more variables defined: stage previous month sales, which has the previous month value of the sales, and stage product, which has the previous product values. So now we saw earlier that the stage variables execute from top to bottom. They are evaluated from top to bottom, and this is why it is important, because when they are evaluated from top to bottom, so you are reading one record, the first stage variable which would be evaluated is this stage sum. Now let's assume that this is the very first record. So your values, you have to define the initial values for these two, which would be zeros. If input product is equal to stage product, so this would be some empty value or a zero value, so it will not be equal to the stage product, and it would go to the else part and just put the input dot sales. That would be for a new product for the first month. Now for the let's consider the first record itself. Now for the first record, it goes and tries to compute the stage previous month sales, input dot sales. So whatever was the sales value for the first month for that product, it has put in this particular variable, and similarly it has the product name or the product ID for the current product in this stage variable. Now go on to the second record, and what will happen? The second record tries to compare the current product name with this value in the stage variable, which is over here. Now this stage variable still contains the value from the previous record, because the stage variables are executed from top to bottom. So for the current record, this stage variable has not been recalculated, and that is why it contains the value from the previous record. And that is how you can compare the previous record value with the current record using the stage variables. Now for this scenario that we're trying to implement, we have to understand that we need to sort and hash partition on the product ID, because we have to calculate the year-to-date sales for a particular product. So you need to partition on the product. Whenever you're using stage variables and making these comparisons, you have to partition your input data on the key columns. And then you have to order by product ID and month, because we are doing a cumulative sum, and every time it is the first month, we are setting the value to this else part, which is we are setting the value to the sales of the first month, and we are not doing any summation. So that's why it is important to order by the month as well. Now remember here that we do not need to partition by month. If you partition by month, then each partition will have only one record, which is for that product and for a particular month. So in that case, this logic will not work correctly. You do not need to partition by month. What we want is that one partition should have all the records, all the 12 sales records for one particular product. Okay, so now the next question explores your knowledge of another feature of DataStage transformer stage, which we'll see. So let's read the question first. So design a job. If active flag is equal to T and year is greater than 2010, then output to first link. If active flag is equal to T and year is equal to 2010, then output to second link. If active flag is equal to F and year is equal to 2012, then output to third link. All of the records to be collected in a separate output link. Now what we need to understand here is all these conditions are all right, and you would need to implement them. but the idea that we're trying to test here is your knowledge of the otherwise link. So basically there are different conditions given to you. Based on those different conditions, you have to define your constraints for those output links. Then at the end, there is a common condition that all the remaining records which do not satisfy any of the criteria, above criteria, should be collected in another output link. Now, instead of writing a complicated constraint wherein you check for all these conditions not being satisfied, a simple way to doing this is to use the otherwise link. So otherwise link, you just need to click on that link. You'll find it in the transformer stage. But the thing that you need to remember here is that it should always be the last link in your order of links in the transformer outputs window. So the otherwise link must occur after all the output links in the link order, and that is the only way it will catch all the remaining records. Okay, if you put it somewhere in between, so wherever you put the otherwise link, basically it just checks for the conditions above that particular link. So if you have, let's say, 4 links and you put the otherwise link at the 3rd position, then it would only check for all those conditions which are mentioned in the first 2 links. Any records that do not satisfy the conditions which are mentioned in the first 2 links would be outputted in the otherwise link. So it will not go and check for the constraint that you have specified in the 4th link. So when you have this condition that you have to create an otherwise link which captures all the records which did not satisfy any of those 3 conditions, then you have to make sure that the otherwise link is the 4th and the last link in the link order. Okay, so testing another function in DataStage transformer. As per the requirement, all decimal values should be rounded to the nearest integer less than or equal to them. How can you implement this? So again, mathematical functions which can be used in transformer. You have 2 functions called the ceil and the flow function. The ceil function, as you can see, it makes it, rounds it up. That means takes it up to the integer which is greater than your number. And the flow function, it brings it down to the nearest integer which is less than or equal to your input value. So these 2 functions, very important mathematical functions, so you should remember those functions as well. Okay, next question. So how can you record job name, status, start time and end time in an audit table? So when you design an ETL job, you need to sometimes have an audit table, ETL audit table, where you need to record all this information so that it can be analyzed upon later on. Mostly in cases when your job has already moved to the production environment, it's in the support or maintenance phase, and all these all this information is very helpful if there is some issue in your batch run or so on. So how can you collect all this information? So again, there is something called the DataStage macros which can be used in a transformer. There are various kind of macros, so you just need to use them and they will give you, these are provided by DataStage. They have their values, default values defined. So DS host name will give you the host name, which is your server name, the project name, so the project, the DataStage project in which you're designing your jobs, your job status, whether it's running or aborted or whatever. A DS job name, your job name, start date, end date, invocation IDs if you're using multiple instances, and so on. So all these macros are available which can be used in the transformer stage to record all these kind of information. So you should be aware of these important macros as well. Now there are many more macros which are available. You can also capture information like the link or name and so on. So the other macros which are available, but these are the most commonly used macros because this is the level at which we need the ETL audit information. So these are the ones which are most commonly used, and we should at least be aware of the most commonly used DataStage macros. Okay, so these were some of the questions which are scenario based, and there were some conceptual questions as well around the transformer stage. Again, transformer is one of the most important processing stages in data stage. So these were some of the questions. You can comment, you're most welcome to comment below if you have more questions on the transformer stage, or if you have been asked some other questions on the transformer stage, then put them in the comments below and I'll try to cover them up in the next session. And we'll have some more videos coming out wherein we'll be covering the other remaining processing stages, like the sort and the aggregator stages and so on. Then questions related to the data stage job execution, the Unix scripts that we need, some questions on SQL, because every data stage project would have some source database or target database or intermediate database, questions on ETL design, some data warehousing knowledge and so on, and some general questions as well. So there will be a couple of videos coming out more in this series, so stay tuned for those videos. And if you have any comments, just put them in the below. You can like, share, subscribe to our YouTube channel as well. So thanks for watching this video, but before we end this session, I have some more slides coming out next, which are going to be about your transformer function. So if you are interested, you can go through those slides. They're just slides in which I have documented some of the important transformer functions. So they are not all, but they are the most important transformer functions, and you should be aware of those functions. They're just a list for your reference. So if you want, you can go through the remaining presentation. Otherwise, thank you for watching this session. Please do subscribe to our channel and stay tuned for the next video.